Thanks for doing electrical for our family.
You're welcome. Pretty
Guess I
soon
can help you.
we'll have a light switch.
I know.
And you won't know what to do with yourself.
This is gonna be amazing. I walked downstairs and you had all the boxes in, and it just looks like so good.
Remember,
it's that little thing that when it's done, the garage isn't gonna look any different, but the fact that we don't have cords running anywhere, and the fact that we can move on with other projects is gonna be huge.
Yeah, I'm gonna miss the extension cords for about like 5 minutes.
It'll be really nice when they're gone upstairs, so I've been tripping over them day and night.
Complaints.
One thing at a time.
Well, today, guys, I'm working on sealing electrical. Yesterday, if you haven't watched that video, I started working on the wall outlets, laying them out, and getting some of the boxes installed. Give that video a watch. It's kind of the first of these videos on garage electrical, and we kind of walk through some of the struggles and the problems with ICFs and SIPs and all of that stuff. I didn't get the outlets done. Maybe I'll do that toward the end of the day today. It's just busy work. It's the same thing. It's repetition over and over and over. So today I want to work on getting things in the ceiling, which is going to be a combination of lights and outlets. I touched on this briefly yesterday, but one of the concerns that I have is the fact that we have an I-joist floor deck. And there are restrictions and limitations on how many holes and where those holes can be located in these joists. They're an amazing material that allows us to span distances that we probably wouldn't otherwise span, and give us a kind of a comfort in the floor that is not easily duplicated, so they're a great option. The challenge really lies in the fact that we have wire going everywhere, and it's not just the wire that's really a problem. We have bathrooms and we have HVAC and kitchens, and so there's a lot of things that actually need to go through this flooring assembly, and we don't have everything crystallized yet, so it's not obvious where, for example, the ducting is going to go for the HVAC. Maybe somewhere through here, and then it has to go to each bedroom and the living areas and such. And then also the soil stacks for the kitchen and bathroom will need to run over here and join the main going out to the septic system. So we know that there's going to be a lot going on in the floor, and because of that, with the electrical, we have a lot of discretion, you know, because there's not really a limitation on the length of the wire per se. So we have a lot of control where to put wires. We don't have to run them in a specific place, unlike the plumbing and the HVAC, where length becomes a major problem. I talked to an electrician about this situation, and I have a couple of different sets of house plans that are other people's houses. And I was kind of looking at the electrical schematic, and it's kind of interesting to me that a lot of this decision making is kind of inferred, or it's left up to the electrician to make the best decision. It's not very crystal clear, this wire goes this many inches from the wall for this far, etc. It's more like we want to switch on that wall and we want it to control that light. And the electrician has to make the decision on how to get power to the switch or power to the light and so on. And so I'm a little bit more detailed because we just need more detail. We're not in this industry, we don't understand the norms, the standards. So we're trying to be maybe overly specific so that there's no confusion and it's more obvious what to do. So today we're going to be wiring the boxes into the ceiling. I'm not going to run any wires. I just want to get the boxes set up where power is either going to be coming into the box from the circuit, or it's going to be leaving the box and either going to a switch or going to a light. And that way, I forgot to mention, we have an electrician coming by in a few days that's going to walk through all this stuff with me and kind of make sure that I'm doing things well, they're thought out, that it's going to work the way we want it to work and there's no issues. And then ultimately to make sure that we're up to code and that when we have an inspection done, it's not going to backfire on us, kind of. I showed this sheet in yesterday's video. This is from the manufacturer of our I-joists, and there are different joist depths, and then there are different series of joists within a depth. So we have a 11 7/8 joist that is a 360 series, and it gives us a table of hole sizes here. We can drill, say, a 5-inch hole, but we have to be 3 feet 6 inches from an end support. So this webbed or hashed area, we're not allowed to drill within that area at all. And in order to drill a 5-inch hole, we would have to be 3 feet 6 inches away. But then to drill another hole, we would have to be a certain distance from that hole, and so on. So this table is something we're going to be referring to probably more with the HVAC and the plumbing, but with the electrical, like I said, we want to be super conservative so that we don't maybe drill a bunch of electrical holes right here, and then down the road it becomes obvious we need to put plumbing right next to it, and then we've got ourselves a structural integrity issue. The layout of the garage lighting was totally just kind of a circumstantial thing. These lights were actually installed way back before our timber frame even existed. We needed some lighting in here for the timber frame workshop, and I just kind of bought whatever made sense on Amazon, kind of counted about how many we needed, and then just went for it. And it's kind of weird, it's actually worked. It's worked so good, it's been in here for coming up on a year and a half now. So I think we're gonna stick with this layout. The way these lights work is they actually have like a regular power cord on them. And because of that, we can actually just run a box over here and put an outlet. And then we can connect 2 lights into that outlet. And so the switch near the door or the stairs will actually just control the outlet, and then by virtue of that, they'll control the light. So what we've done is narrowed down, even though we have, I think, 5 or 6 lights. We have 5 lights on this side and 6 on the other side, but we also have a garage door opener. And that garage door opener is going to be on the same circuit, but it can't be controlled by the switch. So we'll have to kind of work that out and figure out how to make that happen. So we're going to be using the least amount of boxes possible to control all of these lights. Too deep. So what did I do wrong? Totally outsmarted myself. That gap there is actually 1 inch, not 1.5 inches.
this is gonna be our sheetrock depth, and so that'll be about 1/8, maybe 1/4 behind the sheetrock, which will work super good.
Well, kind of as per usual, the first sheet or the first panel or the first box takes a long time, a lot of kind of just figuring things out. So I feel like I've got kind of my spacer figured out. I've got kind of the blocking and the toe nailing and all that stuff figured out. So all that seems pretty good now. I feel like I can just kind of use the system to start rocking on boxes. So we're gonna have a bank of lights on the west side and a bank of lights on the east side, and we're gonna have those controllable from 2 different switches, so we don't have to have all the garage lights on all the time. We actually did this kind of through the winter. We don't really use this side of the garage except for when we're doing projects, because it's more like that side's the living side. So we actually just turned all these lights off, and it was actually more pleasant in here. It just kind of seems industrial otherwise. So what I think I'm going to do, so that I don't kind of commit myself early to these exact lights, is just space boxes every 6 feet. And that way, if we want to change the lights at some point in the future, or take on some other kind of lighting strategy, there's a generous amount of options, but there's not too many, but also just maybe not one, you know what I mean? So let's get boxes about every 6 feet along this side, and then, yeah. Let's try that first. As I expected, that went a lot smoother. I think aesthetically, I like that they're all in a line. I just pulled measurements off of the carrying beam in the middle to the first box, and I used that as a measurement to just set the rest. I don't know that that needs to be something specific, but it looks good all in one line. But there is one problem, and I'm thinking that this I might have to change. This box right here by the opener is basically represented right here. And I wrote 2-gang box, and I put a single up there. The reason I'm thinking this has to be a 2-gang box is that power is coming in from here to feed this light circuit, and then will be daisy chained over here. But that means that there's 2 wires coming in, 2 wires going out, 2 wires going out, and then we've got wires coming in from the switches from either side, because this is going to be a 3-way circuit. And then I'm actually going to be bringing power not switched over here to the wall in case we want to put lighting on this wall, like in a cabinet or something. But I want that to be on the lighting circuit. I don't want to have to draw power from outlets or something. So if you count, that's 2, 4, 6, 8, 10 wires. And in a box, the grounds all count as 1. So I believe we'll have around 11. 2, 4, 6, 8, 10, 12. Oh wait, no, there's 10. Yeah, 11 total wires in that box. The problem is that if you look really deeply in this box right there, you'll see that these boxes only allow 8 number 12 wires. and that includes the ground. So if we jump up to a double gang box, this one allows 14 number 12 wires. See it there right below the cubic centimeters? It says 16 number 14s, 14 number 12s, 12 number 10s. So we can put 14 number 12 wires in a double gang box, or I guess I should say more specifically, a 32 cubic inch double gang box. So we need something bigger, I'm pretty sure, to do what I want to do there. That single gang is going to have to go away. I think standards like this can be a little bit confusing because we only plan to put one outlet in that box. I think if we were to put 2 outlets in that box, we would be adding 2 more wires because that's wires in the box. So we're going to be putting all those wires with 1 outlet in a double gang box. You follow? Since we're on the topic of boxes, this is probably a great time to bring up the cost difference between, say, this box, although, okay, so use your imagination here for a second. Imagine this box is this quality. See the quality difference? A little bit of a difference there. So this one isn't exactly the box I'm talking about. Imagine this box was made into a double gang. So this little box right here is 21 cents. The equivalent box here is about 68 cents. So 21 for a single, 68 cents for a double. This box is $1.40. So this box is almost 2.5 times more expensive than the equivalent of this style, the nail-on type. Because these are just the standard. For stick-built construction, it seems like pricing pretty much tells you everything you need to know. Everybody buys this style of box because why not? It makes sense. They've got nails already in them. You don't have to have fasteners. You line it up. They've even got little ears on here for the sheetrock depth. You basically pull that up against the stud and that sets the depth of the box for the sheetrock and you nail it on super fast, right? So where possible, we're basically using these boxes and we're just pulling the nails out and using the box as is. Take the nail out, screw it on, 21 cents. You buy this box, same box, has a little bit of an ear on it for fastening, and I think these are like $1.20 or $1.30, so 5 or 6 times more expensive. And if you look at it, it's the same box. In fact, there's not even any nails included. You have to provide your own fasteners. So my point with that is, when you're doing construction, I guess if you're thinking of going traditional versus unconventional, and if you get to a stage like this and you want to think about how to build, you can start saving a tremendous amount of money, because if we put 100 of these boxes in the house, that could be $100 more than these boxes. You get the idea. So I'm kind of jumping ahead a little bit to the actual pulling wire phase, but let's just briefly touch on it. Sat here for a little while and kind of stared at these home runs and wire runs and stuff. There's a really important code requirement that comes into play when you start pulling wire. There's a code that says that you're allowed 3 cables or wires in a 1-inch hole. And I haven't read the code to understand if you go to like an 1.5-inch hole or 2-inch hole, or does that change? The reasoning for the 1-inch hole is if you're drilling in a 2x4 stud, the stud is 3.5 inches thick. If you drill a 1-inch hole, that leaves 1.25 inches on either side of the hole if you put it right in the middle. That's important because if the wire is closer to the surface of the stud than 1.25 inches, you have to nail plate. So this nail plate here is there because this plumbing is less than 1.25 inches deep, and the same rule applies to electrical. So anywhere you get too close to the surface, you've got a nail plate, and these guys are not cheap and they're laborious and it gets tedious and all that stuff. So if you can, you want to stay deeper than that. And I think that's the origin of the 1-inch hole and the 3-wire rule. Is the 3-wire rule has to do with fire. So there's 3 wires in that 1-inch hole, and the 1-inch hole has to do with 2x4 construction. So we've got 3 wires in there, and if you measure that, hopefully there's 1.25 inches on both sides of that hole, and therefore we don't need to nail plate that area. That's a long roundabout way of basically saying that we're going to be drilling 1-inch holes in the I-joist, and we're going to be running 3 wires per hole. Obviously, we want to minimize the number of holes, right? We went over that earlier. So staring at the diagram, I think I've got this sorted out so that I can run one set of holes from end to end on each side of the garage, and we can get all the wire through them that we need. Like I mentioned earlier, this diagram is not accurate because this wire is not truly going to go in that orientation. It's actually going to come across a joist, which requires no holes because those joists are running east to west. And then there's going to be a set of holes where this dashed line is. We can join that and bring this wire through that hole. Then these wires are going to join in that hole until they get back to here or wherever they're going to go, say here. And then they'll come over to this box. And moving laterally this way is actually pretty easy on a joist. It's moving through the joist that we need to be conservative. And we can only put 3. So I know that looks like a mess and it's a lot of words, but kind of jumping ahead and trying to explain why I'm putting boxes where I am so that it makes sense for running wire also.
Totally made the mistake. Oh no, I cut them all too short. So what happens, guys, when you take these measurements but you forget to add the flange? So I get to go do all of these boards again. Boop. Actually made an executive decision to move this box over here because all the home runs and all that stuff's actually going to be in this joist bay. We're going to be bringing power over here. I pulled that box off because that's going to be a double gang. I'll share in a minute. This is actually worse than I thought it was originally. I'll share why in just a second. But this guy right here has got to move over here, and that way there's no need to go between joist bays. We can keep pretty much all the home runs and stuff right in there. Yeah, hopefully this fits in here. Oh yeah, nice. Go there. That's a little snug, actually. Go right in there. Let's see, I think that was like 7/16 in, so we'll just put him 1 inch. Oh yeah, then there's room to come in the side there. There we go, that'll work. That's too big. Now we gotta move this. measure that right there. Sure looks like it's too much to me. Yeah, it looks way too much. So I don't know what's going on there. That's actually pretty tidy right there. I mean, it's a little more, it's a little over. So I'm not sure what's going on with that. I guess there's no reason not to push that up. Yeah, let's see. And then that cover actually fits inside of that. So I don't think we really want it to stick out, or we don't need it to stick out. Man, did a horrible job getting those boxes on there square. Sticking out slightly. Man, the whole thing's just like cattywampus. That's better.
All right, so we are really honking. We've got all of the ceiling boxes on the west side, all of the ceiling boxes on the east side. We've got power to the garage door openers. We've got each box for the lights. We set the 2 junction boxes where power is going to be coming in from the light circuit and where power will be coming in to feed these south wall outlets. So why is this a worse situation with these 2 gang outlets than I originally thought? Someone mentioned quite some time ago in a video, a comment, that they really appreciated having switches all over the place to keep them from having to go upstairs or downstairs to turn lights off that they either forgot to turn off or they noticed are on or whatever. And we're going to be trying to really optimize the house for that convenience. And one way we're going to do that is with 3-way switches. So everything in the garage here, near the entry and near the stairs, is going to be a 3-way switch. There's going to be somewhere either upstairs, in the case of the stairs, or at the door and the stairs, etc. So you can go from here to there and all the lights can be turned on and off. The problem is it takes a lot more wire to make these switches work than a normal switch. I think I'm going to play with this in a different video, more for fun and kind of learning. These are the 3 basic ways that you can wire a 3-way switch. And it really depends on what's efficient, where the power's at, where the lights are at, and kind of what's the most convenient way to set things up. No matter how you look at it, there's a lot of wire. There's a lot of wire coming into the box and then going from switch to switch. So that's why these boxes are going to be more of an issue. So originally I thought that there was going to be 2 wires per thing, right? 2, 4, 6, 8, 10. But the problem is this wire coming in from the switch very likely is actually going to be a 12-3 wire. So that means that there's actually 3 per here, 3 per here. So that's 3, 6, 8, 10, 12. That's a lot of wires, guys. I'd originally, kind of while I was working on this other stuff, my brain was kind of thinking about how to be more efficient with this stuff. And I was thinking, oh, if I pull some of that wire out of there, maybe I could get away with a smaller box. But at this point, it looks like we're committed. We're definitely gonna have to do a double gang box. And it's not that big of a deal, but I think we're always trying to find ways to be more efficient and optimize. And well, we're stuck with a big box. These 2 junction boxes here, I'm not 100% sure this is exactly what we need to do here, but I went ahead and put it in anyway. It'll help me have the conversation with the electrician. So basically, one of these is going to be the source of power to the lights from the panel, and we're going to split that off into a bunch of different areas, and then the other one will be power that'll come down the outlet to this post, and it'll also feed the outlets on the east and the west walls, and that's why we have to put a junction box in. And code says that you have to be able to access those junction boxes once the wall surface is on. So those actually have to stick down and be accessible through the sheetrock. So that's why they're actually hanging below the I-joist there. Yesterday, I called a few friends and asked them for their advice, apple or banana, to decide which side of the post these outlets should go on. And the consensus was apple, which is this side. But I think to keep things balanced, we're gonna put one on the banana side of the other post. For cosmetic purposes, we're actually gonna be using an outdoor box here, just because it looks nice compared to like one of these more like industrial boxes. This is not a perfect example, but you can see how this is more industrial looking, and this kind of has a more finished look. We'll be using conduit to run the wire up into the ceiling, just because that's required by code. But this will have just a normal outlet and a normal cover plate on it. I think we can get those installed today, and maybe a couple other things, and I think that's just pretty much going to be it for today. I almost forgot one super important detail. If you're wondering what this really weird shirt is all about and you don't know, we'll link to the video in the description. It'll tell you everything you ever wanted to know about skid marks.